I've just flipped this tiny switch and pop! The whole room lit up in a flash. Not magic. That is electricity at work. But how does it actually move? And what happens when the hidden track inside the wall gets broken? Let's take a look. To see the answer, we have to shrink down smaller than a bug and travel right inside the wire in your wall. Now that we are super tiny, look around. Zooming along this track are teeny tiny pieces of energy called electrons. They are too small to see with our eyes, but they are always on the move. Meow, did you say elephantrons? Look at them go. Not elephants, kitty. Electrons. Electricity happens when millions of these tiny electron dots move together as a team. When they move, they carry energy to your lamp. This diagram shows the round track, the circuit. Electrons start at the battery, zip along the wire, and light the bulb. Watch this. A switch acts like a lifting drawbridge. The path breaks, the dots stop, and the bulb goes dark. The electrons need that circle to be closed and complete to keep running. If the loop breaks anywhere, the energy stops. Meow, a long journey just to light my nap spot. But where does the electricity in your walls come from? How do all those dots get into your house? Far away, massive buildings called power plants get those tiny energy dots moving. They use the push of blowing wind or rushing water to shove electrons into the wires. Once they get that push, electrons travel a long journey, zipping through miles of wire across town to reach you. All that hard work from those giant machines and the miles of wire happens to keep the track in your wall full of electrons, ready to light your room. Meow. In winter, if I rub a balloon on my fur, my hair stands straight up and I feel a tiny zap. That zap is static electricity. It happens when electrons can't move in a loop, so they bunch up in a big traffic jam until they finally jump all at once. This slow-motion video shows a real lightning strike. Lightning is a giant, super hot version of that same static jump happening right in the sky. Look at this bright yellow safety shield. Because moving energy is so powerful, we have to follow the rules to keep it helpful and safe. Never put toys in an outlet. Let grown-ups handle the cords. Keep electricity away from water. Meow. Being smart and safe is our golden rule. That way, the energy stays on its track and does its job. Whew, that was serious. Meow. Hey, why did the light bulb do so well in school? Because it was so bright. Ah, silly kitty. Now it is time for the Junior Explorer Challenge. Let's see what you remember. Get ready to shout out the answer. What do we call the tiny moving pieces of energy on the track? Electrons. Awesome. And what is the name for the full loop the energy travels in? A circuit. Great job! Knowing those two words means you understand exactly how those lamps and toys get their power. Today, we found that electricity is really just energy on the move, zipping around in those safe, round loops. Now you have a mission for home. Ask a grown-up to help you rub a balloon on your hair and see if it sticks to the wall. It's a great way to see static electricity in action. Meow! You did it, explorers! Subscribe to join us for our next adventure and see how the world works. Stay bright and safe.